and welcome to a lesson on arithmetic sequences. We will go into more detail what the word arithmetic means in just a moment, but sequences refers to pretty much a pattern of numbers. A very basic example will be 1, 2, 3, 4, 5, 6, 7, 8, where it's going up by 1, or 2, 4, 6, 8, 10, it's going up by 2s. But what we're going to do is we're going to look at some equations and see how they can represent sequences, patterns, and also how we can properly graph this. So let's go ahead and take a look at an example on page 156. So we're going to first take a look at something called an explicit rule. An explicit rule, guys, is what you've actually been dealing with this whole time, where you just put in a number and out pops a result. That's the most basic way to put it. And what we do for sequences, guys, is we have, instead of x, we have n. N represents the number or what number term it is. So the first 4 numbers in a list would be represented as n1, n2, n3, and n4. And all we have to do to figure out what the pattern is, guys, is just take these n's right here and put them into the equation. So let's find f of 1. All we're going to do is replace the n with a 1. 1 squared is 1 times 3 plus 1 gives us a 4. So the first number is a 4. Let's put in number 2. Well, 2 squared is 4 times 3 is 12 plus 1, 13. Okay. What do you guys think the next number is going to be? Let's put in a 3. It's 28. Let's put in a 4. It's 49. So we'd say the first 4 terms are 4, 13, 28, and 49. It doesn't look like they're really following much of a pattern, right? Where they're adding, this one adds by 9, and then this one goes up by 15, and then this one goes up by 21. So there's a pattern to this that we could easily make out, but that's how you'd use an explicit rule. Now, there's another rule that we could talk about that represents sequences. We haven't even talked about arithmetic yet, and that is called the recursive rule. So first off, do you guys see how in explicit we just put in the number and it just explicitly gave us that? Recursive is a rule representing an equation where it builds off the previous answer. So for example, 1, 2, 3, 4, 5, 6, what would be the next number? 7, right? And you know that because 6 plus 1 is 7. That's what this is right here, where it tells us what the first number is. F of 1 is 4. And then it tells us for any number we're looking for, this n minus 1 means let's look at the previous answer and add 5. So for us to calculate the first 4 terms, just like before, we look at the first term of a sequence, which is 4. So I find f of 1 equals 4. We start with 4. But then what we're going to do to find f of 2, we look at the previous f, which is f of 1. And f of 1 was 4. So f of 1 plus 5 becomes 4 plus 5. And 4 plus 5 is 9. You guys might be able to see a pattern here already. Because what do you think the next number is going to be? Let's find out. To find the third term, f of 3, I'm going to find f of 2 and add 5. F of 2 was 9. See that? F of 2 is equal to 9. So I'm going to put a 9 here. And I add 5. And that gives me 14. 4, 9, 14. How is this going up by? Isn't it going up by 5? So shouldn't the next one be 19? But let's find out. To find f of 4, I take the previous f, which is f of 3. And that gives me 14 plus 5 is 19. So take a look at this, guys. This right here is an arithmetic sequence. Because arithmetic means a pattern of numbers that changes by addition or subtraction. So that was an example of a recursive rule. And we saw an example of an explicit rule. And the hardest part about this, guys, is I think everyone here can do plus 5 plus 5 plus 5. The hardest part about recursive and explicit rules is just interpreting what the equation meant. And the quicker you tell yourself that f of n minus 1 just means the previous answer and then plus 5, the easier it's going to be. And that's actually it for our lesson, guys. We are going to just practice this much, even though our goal is to eventually graph this kind of stuff. We're just going to practice this much before the next class, okay? And then we'll go into more details in class. This is a complicated part. In fact, I find this to be like one of the hardest parts of Algebra 1. So take it easy, do your best, and we will go over quite a bit in class. Otherwise, make sure you do your homework and have a good day.